our robot, our aim was to use economical and less complex machining. We started with the CNC machining of the aluminum chassis. The reason for using aluminum as the material was its malleability and durability, as well as its resistance against corrosion in the presence of water. We cut the chassis using CNC milling machine according to our design dimensions. Additionally, the reason for choosing PLA as the main material of the body was to keep up with the 12th goal of the United Nations Sustainability Goals, which is responsible consumption and production, as PLA is a bioplastic that is biodegradable and eco-friendly. Then we painted the 3D printed body parts with a spray paint suitable for thermoplastics. After manufacturing the chassis and the body, we attached them all together to create the robot's body using metric force screws, nuts and L-brackets after drilling the holes onto the chassis and the body parts with the drilling machine in the workshop.
To manufacture a suitable brush for our robot's purpose, we found a company in Turkey, gave them the desired dimensions according to our design, and we received it. The material choice for the bristles of the brush was essential, so we paid attention to their smoothness to eliminate the solar panel from getting damaged. After we received the brush, we manufactured the brush cover using FDM 3D printing with PLA according to the design dimensions. Also, we used FDM 3D printing to manufacture the key bushings we designed to attach the brush with the DC motor and the cover by inserting the bushings inside the brush shaft hole. Then we drilled the brush cover manually by heating metric force screws before inserting them into the cover. After assigning the brush system, we purchased the water pump, tank and hose and attached them onto the main body using silicone gun. The reason for using silicone gun was its ability to withstand to UV exposure, which made it suitable for outdoor applications. Again, with the same method of using heated metric force screws, we drilled the hose on top of the brush cover to supply water from the tank to the pump.
We designed the robot to be as simple and compact as possible, which is why we went with a simple box design, which was 3D printed. We used a sliding lid mechanism to allow easy access to the components inside the robot. The entire system cost just under $700, which was well within our budget constraints. We used mecanum wheels on the robot for more mobility, so the cleaning time would be faster for the robot. The weight of the robot was just over 5 kilograms, which is about half the weight of the previous project. The size of the robot is 41 centimeters by 37 centimeters, and the height is about 24 centimeters, which is also about half the size of the previous project.
Our innovative solar panel cleaner robot is designed with both efficiency and sustainability in mind, aligning perfectly with the United Nations Sustainability Development Goals. Central to our robot's operation is a powerful 11.1 volts, 14,000 mAh lithium-ion battery with a 25C discharge rate, capable of powering the entire system for up to 2 hours. For precise and reliable movement, we have integrated Namo 70 stepper motors driven by DRV 8825 motor drivers, known for their high performance capabilities and efficient heat dissipation. The cleaning mechanism employs a 12-volt DC motor with a gearbox, controlled by an L298N motor driver, ensuring optimal torque and cleaning effectiveness. For maximum operation, we put every electrical component through a testing process. We tested our circuit on a breadboard at first, but then moved it to a variable. The Raspberry Pi 4B with 8 GB of RAM, which is the main control in our semi-autonomous robot, has a stable 5-volt 3-amp power supply that is stabilized by a separate regulator. The Raspberry Pi communicates seamlessly with an Arduino Uno using serial communication, where the Arduino is tasked with motor control and ultrasonic sensor integration for autonomous navigation. Our robot makes a positive impact on the environment by keeping solar panels clean and effective, which maximizes solar energy output and reduces dependency on non-renewable sources.
Our robot is equipped with several technologies that work together. Our main control unit is Raspberry Pi, which is connected to a camera, as you can see here. We are going to use case for controller to control the motion of the robot. The Raspberry Pi will receive the direction of inputs, then send them to the Arduino, which is responsible to control the stepper motors that drive the mecanum wheels, as you can see. For real-time monitoring, we connected the camera to an Android app. This app provides us a clean visual of the cleaning process. This integration allows us to have a convenient monitoring, which means we can oversee the robots from anywhere.